So let's go ahead and quickly look at question number 2 and check our answer. Of course, we're going to use rubies, so I'm going to go ahead and write rubies down now. Let's go ahead and read once. Trapezoid ABCD is similar to trapezoid EFGH. What is the length of side HG? We're going to read it a second time. This time, we're going to underline important words and box numbers. Trapezoid ABCD is similar to trapezoid EFGH. What is the length of side HG? Well, first thing that we look is we can see that side HG is here on the second figure. Let's go ahead and box that and its corresponding side of DC. Well, inside HG, since that's what I'm looking for, I'm going to put a variable. So I'm going to put an X there. I also want to see what else do I know. So where else do I know the values for both of the sides? Well, I can see here at EH, I know the value, and at its corresponding side, AD, I know the value. So now, using this information, I can actually create a proportion. If I look here, I actually already have a proportion set up because they are right next to each other. These figures are right next to each other. So if I look at it another way, I really could draw a line that connects these two, and then I see my proportion right here, where my equal sign would go, right in the middle. 20 is across from 15. 13 5/10 is going to be across from X. So let's go ahead and write that out. 20 is across from 15. 20 is over 13 5/10. And 15 is over X. Now, since we do have to do some cross multiplication here, we're going to need a little bit more space. We're going to go ahead and turn over to the back. So I'm going to write that same exact problem, 20 across from 15, 13 5/10 across from X, our equal sign, and fraction bars. Now we're ready to cross multiply, where we're multiplying 20 times X, 15 times 13 5/10, and we have our wall. So let's go ahead and take a look. We rewrite the problem as 13 5/10 times 15 is equal to 20x. This is a step many of us forget, but it's very important to rewrite our problems and make sure that we're very clear on what we should be multiplying. We can make very silly mistakes if we are not checking what we should multiply. Well, now we can see that we're multiplying 15 and 13 5/10. So let's go ahead and make some space for that. 13 5/10 times 15 using the lattice method. Gonna break it up so that I have a column for each one of my digits and a row for each one of my digits, and breaking each one of those boxes into its tens and ones column. So starting with my ones, well, 1 times 1 is 1, 1 times 3 is 3, 1 times 5 is 5, 1 times 5 is 5, put in my zeros, and now I'm ready for my 3s. 3 times 5 is 15, and finally my 5s. 5 times 5 is 25, so I end up with a 5. 5 plus 5 is 10, plus 2 gives me 12, carry that 1. Then I have 1 plus 1 is 2, plus 3 gives me 5. 5 plus 5 gives me 10. So I'm going to go ahead and carry that 1 again. 1 plus 1 gives me 2, and my answer is 2, 0, 2, 5. Remembering that I have one place after my decimal, I'm going to move that place over one time. Well, now, when I go back to my problem, I'm going to write 205 tenths is equal to 20 times x. When I'm looking at this, just by looking at it, I already know that my answer should be somewhere around 10. So when I go back and continue with my rubies, I can now actually eliminate just based on what I see. I know my answer is probably not going to be 8. It's also not going to be 9. It's going to go in at least 10 times. I can see that because I have the number 200 and I have the number 20. So let's find out how many times does 20 go into 202 and 5/10. So we write it out, 202 and 5/10. 20 goes on the inside, 20 goes into 21 time. 1 times 20 is 20. We subtract and we're left with 0. We bring down that 2. Well, 20 cannot go into 2, or it's not going to give us whole numbers. So we're going to say 0. And now we can already see that we have that 10 that we were talking about. Well, 0 times 20 is 0. We subtract. We're going to be left with 2. And now we're bringing down in that 5. Well, 20 goes into 25 one time. 1 times 25 is 20. We subtract. We're left with 5. And we bring down one of our imaginary zeros. And now we are having 20 go into 50. And that's going to go in 2 times to give us 40. We subtract. We're left with 10. And finally, we're going to bring down one more 0. And 20 is going to go into 100. 20 goes into 100 5 times. So finally, when I divide both of these sides by 20, I end up with x is equal to 10. I apologize. All those 2's. X is equal to 10 and 125 thousandths. Let's go ahead and check. Is that an option? Yes, it is.